Hello, I'm Dylan Day. I'm here with Connor, Evan, and Louise, and we're going to be talking about the experiment recycling aluminum. First, we have to start off with our procedure, our purpose. Sorry, our purpose is to prepare a sample of potassium alum from aluminum and to determine the percent yield of that product. So over here, I have our materials that we needed for our experiment. We had to have aluminum scrap, which we used like Pepsi can. Scissors or tin snips so we could cut the Pepsi can. We needed a 250 milliliter beaker so we can put the aluminum scrap in it. Then we need 1.55 molars of KOH, and then 9 molars of H2SO4. We also needed a Buchner funnel and a filter flask.
Some things that we should know for make this experiment are limiting reagent, that is reactant in a chemical reaction that determines the amount of a product produced. Stoichiometry coefficient, the number that is in front of the compound in the balance equation. And as last, excess reagent, reactant in a chemical reaction with greater amount than the necessary to react completely with the limiting reaction.
For the procedure of this experiment, we wanted to make sure we had glasses on and an apron so that if any volatile chemicals spilt out, they wouldn't get on you and hurt you in any way, shape, or form. You need to accurately weigh 0.5 grams of aluminum scrap, and you need to cut them up into little tiny pieces. You want them about that big, and you need a bunch of them. You want to put them into a 250 milliliter beaker once they're cut up, of course. Then you put them under the fume hood and you get 1.5 molar KOH, and you need to be very careful not to spill this stuff. It's caustic. You need to heat the beaker gently over a flame or on the hot plate, which in ours we use the hot plate. Large quantities of H2 will be evolved. You should hear some sort of fizzing. Once you've started the reaction, it takes about 30 minutes on the hot plate. You want to heat it up until there's no fizzing or until you see no more aluminum. You need to drop, if the volume drops between a half of the original volume, you need to put some distilled water. The best thing to do is put it in that little squirter bottle and squirt it in there. Just be very careful not to splatter it. Then you need to use your tongs to remove the beaker from the heating unit so you don't burn your hands. Nobody likes burnt hands. Then you can use the glass rod to remove the small pieces of the solid. The solid that would be left in there would be the paint from the can, like the Pepsi logo and whatnot. In order to remove that, you need to filter the solution through a glass wool or use a filter paper. The best thing to do is to fold it up and stick the filter paper into a funnel and let it drain into another beaker. Once the solution's cooled for about 5 minutes, 5 to 7 minutes is a good time. Then place it in the ice bath so it'll cool down completely, so there's no more hot spots in it or anything like that.
Alright, so to continue with the procedure, step 9, while stirring, slowly add 9 molars of H2SO4 until pH paper shows that the pH is about 1 to 2. A volume of 2 to 5 milliliters of acid may be required. Let's see, large lumps of aluminum OH3 may appear initially, but these should redissolve upon further acidification. Now step 10, heat gently for 10 minutes at 60 degrees Celsius to 80 degrees Celsius. Don't boil it. Or until the aluminum OH3 dissolves. And then just periodically check the pH levels. Don't heat more than 20 minutes. A clear solution should result. Step 11, remove it from the heat. 12, cool in an ice bath for 20 minutes to form crystals of potassium aluminum compound. 13, collect the crystals by vacuum filtration. And let's see, Step 14. There should be a little bit of excess water on there, and step 14 talks about to remove excess water from your crystals. Use a disposable pipette to slowly add 10 milliliters of cold methanol, and that should help get the water off a little bit, the excess water. Step 15, remove the top part of the funnel, and then transfer the filter paper and the crystals to the watch glass and allow the aluminum to dry in the drawer. And we did that for, I believe it was a week. We left it in our drawer to dry, and then the following week we came back to get the mass. So that was step 16. Determine the mass of your aluminum crystals. Transfer the crystals to a glass vial and label it with your name, the formula, and the mass.
So at the beginning, when we had to cut up the Pepsi can to get the aluminum scrap, we ended up with 0.52 grams of aluminum. So then, when we added the 9 molars of H2SO4, it all started clouding up and chunks of solids were forming in the beaker. So then we had to find the mass of the watch glass. So that was 88.69 grams. And then the mass of the filter paper, which was 0.38. These were combined together, so we had to add them up, and we ended up with 89.07 grams of the filter paper and the watch glass. Alright, so after we found the mass of the watch glass and the filter paper together, we come over here, and we had to find the mass of the crystals. So after we waited the week, letting all the crystals dry, we have the 93.01 grams, which is the crystals, the watch glass, and the filter paper added up all together. So we have to subtract 89.07 grams, which is just the filter paper and watch glass, from the 93.01 grams to get the mass of the crystals. So we ended up getting 3.94 grams of crystals.
Some of the errors that we have, well, the first one was that we didn't cut the little squares of aluminum at the beginning, so it was a little bigger than what they were supposed, so the reaction was slower. Then our second mistake was our pH wasn't the ideal. Then at the end we didn't mix the product, so we don't know if we missed some of the salt. And our last error was that when we changed from one week to the other, we changed our watch glass, so we didn't use the mass of the first one, we used the mass of the second one.
During this experiment, we were able to calculate the mass of the aluminum after we performed all the processes that were listed in the procedure. There were several errors, as my fellow classmates listed. This would have caused a different mass at the end when you weighed them. It could, if you did the experiment wrong, it could result in a very small mass, or if you weren't careful and spilled some, you could also have a very small mass when you went back and weighed it again. And overall, all these errors that went on through the class, it could consist in a very inconsistent mass throughout the experiment.
Yeah, so that concludes our experiment. The sources that we used was the actual lab handout for experiment 5 and this doohickey right here, this awesome chemistry book.